We're pretty frustrated that our vertical drilling operation this year didn't solve the mystery of the huge object and the smaller anomalies that we've detected with GPR and even hit while drilling in the past. But we did bring up more metal fragments from about 60 to 70 feet deep that have no business being inside solid sandstone. And then we've got the Type A and Type B ceramic materials that were extracted last year at different depths. We've only been able to test Type A so far, but the results suggested they could be related to spacecraft technology.
We've got a new member of our team here for the first time, Chris Roberts.
Chris.
This is the gentleman responsible for the samples that we brought in to date.
So we're hoping that Dr. Clark and Dr. Patchett can help us learn more about all this stuff and what it could mean about what's buried in the mesa.
So I understand that we have the opportunity to use a technique called FTIR in our analysis of some of the materials.
Now, I haven't spent a lot of time in a science lab, so I'm not familiar with these terms. What's FTIR? What does it mean and what does it do?
FTIR is Fourier Transform Spectrophotometer, and basically it can tell us if there's a carbon-oxygen bond or a carbon-hydrogen bond.
What does that mean?
Well, it means we could possibly date it.
With the FTIR, we will take a beam of infrared light and we will point it at the sample. This will help us determine what kinds of bonds are in a sample. If we see carbon-hydrogen bonds, we might be able to use the samples found at the ranch for radiocarbon dating to find out exactly how old they might be.
So at headline level, we're looking for insights into how was this material made and maybe when.
Yes.
Okay.
When would be great.
Okay.
All right. Well, what do you say we get some samples under test?
I was going to say, we got precious minutes here at the lab. Let's make use of it.
Let's make use of it.
That's fantastic. Well, I will leave you guys with Dr. Clark.
Right.
Earlier this year,
Well, guys, Chris has been looking at the properties of these materials that we brought out of the mesa.
Chris found organic buildup on both types of the possible ceramics, which is caused by being buried a very long time. He estimated more than 1,000 years. Now, if that's true, it's crazy because they appear to have been machine-made. But when we recently had experts from Artemis Labs in Colorado analyze a sample of Type A, they were unable to date it and couldn't even identify what it was.
So, Chris, which of the samples will we begin with?
I'd like to start with Type A.
Okay.
And then we'll go to Type B.
Okay.
So now we're ready to go with the sample.
Yep.
If I can get this case open. This is the Type A.
So that's a nice flat piece. So we're just gonna bring that nice and snug.
I'm in suspense.
Okay, well, let's try it. We'll see what happens. You can see that we do have little absorbances there. They look like little peaks, upside down peaks.
So that means there is some carbon in it?
It could be.
So would we estimate that we have enough carbon dating information?
Yeah, it looks like it does have carbon-hydrogen bonds there, so depending on the sensitivity of that procedure, it should work.
Wow. Whoa. When Dr. Clark told the guys that the Type A sample might be able to be carbon dated, that was pretty awesome news. The only bummer is that carbon dating these samples will need to be done elsewhere and it'll take more time. But at this point, we're happy with anything that feels like progress.
I feel like we should look at another sample while we have the opportunity.
Yeah, well, we can.
It's right here. This is the Type B. Under a black light, it actually seems to absorb light, so it goes darker than it is there. And this is the only piece we have of this material.
Okay, I will be very gentle with it.
I'm anxious.
Oh,
Whoa, whoa.
What is that?
that's not the same.
It's not absorbing any infrared wavelength. It's just reflecting the light.
You said it's effectively reflecting all the light back. So there's no carbon?
Right, yeah.
Interesting. Can you bring up Type A for comparison?
Yeah, okay. Okay.
Whoa, look at that.
That's huge.
Wow.
This is qualitatively different.
Yeah, this doesn't look anything like the same. This proves that this is definitely a different material.
Yeah, definitely.
All right, guys, that piece of material definitely goes into the scanning electron microscope.
Oh, yeah.
Okay.
High priority.